HVAC 360 is brought to you today by Lunch Lady Roach Coaches. With school cafeterias turning into fast food warming kitchens, lunch ladies are losing their jobs at an alarming rate. To combat this injustice, the fine folks over at Roach Coach International, purveyor of more than edible food to job sites globally, announces its newest franchise, the Lunch Lady Roach Coaches. Forget that packing. Forget dealing with those fancy so-called food trucks, or that unreliable apprentice to get your order right. Get your meals hot, ready, and with a hairnet. Daily specials include Sloppy Joes, turkey, potatoes, and gravy, beans and franks, and let's not forget our ever-popular Friday favorite, cheese sheet pizza. That's right, no crust, super thin, and extra greasy. Support your local lunch ladies at your job site today. Hey everybody, welcome back. Matt Nelson here, your host for HVAC 360, helping you be the best and the brightest in the field of HVAC. Each week I'm either sharing information and lessons learned from the field or talking with industry experts. But I don't stop there. No siree. I want to encourage you to double down on your weekly helping of HVAC knowledge by hopping on over to HVAC360.com and joining my growing community of people just like you. So, what's up for this week? This week we're going to talk to Thomas Cocker, who is a commissioning engineer, and a really great story of how he became one of those. There's really so many gems in here. I want to make sure that you listen to the whole thing. I got to give special props to Thomas for actually doing this interview, not once, but twice. Yes, I goofed up and didn't record the episode until we were almost all the way through. Yikes. Fortunately for everyone, Thomas was gracious enough to stick around and do it again, all 45 minutes worth for those keeping track at home. So a big thank you for him, for giving me another chance. And let's just, enough of chit chat, let's just get to the tape. All right, today we're talking with Thomas Cocker, who is a commissioning engineer for Page Sutherland Page. How are you doing today, Thomas?
I'm good.
All right. So can you tell me a little bit about your journey, how you got into commissioning and what you did?
Well, so it pretty much all started back at university. My university essentially had interviews that you could do on campus. You just sign up and then you can sign up for a slot, and then you can go interview with a bunch of different companies. And one of them happened to be Engineered Air Balance, and the interview went well, and they gave me the highest offer out of the rest of them. So basically, it came down to money, and so I just took that position, and I got lucky because I started out in the field of test and balance, and got to see the industry from the field first. And then from there, through the years, I heard how good, how one would want to move up and become a mechanical designer to further your career. And so, after about 4 years, I decided to move on, and I found a job at DBR Engineering Consultants. And there I was a mechanical designer and a commissioning agent. And essentially, DBR already had a senior level commissioning agent in the Houston office, and I was currently in San Antonio. And so he mentored me, through the 2 years I was at DBR. And then also I did design engineering as well. So the design engineering side ended up being more boring than I thought it was going to be, where essentially I drew a lot on the computer and kind of sat alone. They talk about how you'll be part of the design team, but really the only team portion of it is, coordinating with electrical to make sure your stuff isn't going to interfere with theirs, and then coordinating with plumbing to make sure that they have a drain for your condensate. So I kind of got tired of that quickly, and I just wanted to focus on commissioning. And so I also wanted to move to Houston, and I found Pennington and Associates was looking for a commissioning agent, so I signed on with them and became project manager there for about 2 years. And then I got a message on LinkedIn from Paige Sutherland Page to give me an increase in salary and a decrease in responsibilities. So I just thought I could use the extra money, and it's always better to do less work, I guess.
It's a win-win situation.
Yeah. So I went to Paige, and then I love this company. The people there are amazing, and it'd probably take a lot to really ever leave this company. And they even, they're all aware that I started a side test and balance business, and they were all for it. And so I have that on the side, and I do, my main job though is still commissioning.
Right. Now, and that allows you to also provide, quote unquote, third party commissioning, right?
Right.
So, and I what I love about your journey necessarily, and, obviously, networking, is key. That's one of the things you can obviously see. Your journey benefited a lot. You had a pretty, direct, path to where you were going. There was not a lot of, side, distractions as you went through. But the fact that you started in test and balance now, and it's really to me, it's kind of I don't know many mechanical engineers. I don't know. Is that your degree in mechanical engineering?
Yes.
So I don't know many mechanical engineers who had a degree that would go work for a test and balance company. Can you tell me a little bit more about what the makeup of engineered air was?
Yeah. So engineered air balance pretty much only hires engineers. They're one of the top level companies, and I think they're also one of the oldest companies that do test and balance in the U.S. because they were started in 1956, and so I got all my base knowledge from them. And basically, whenever I had an engineering question, there was always someone there that could do the math and work it out, and they don't have to go to the technician's manual and do these just look at the little algebraic formulas that are already established with the standard constants. They could derive them. And that was nice to help me really see how everything worked. And it really helped me out in engineering as well, that I could see how airflow really moved. I could traverse and really see how elbows affect airflow. And I take, differential readings on coils for chilled water and hot water. And I could really see what the water essentially was doing and how it would balance, how annoying it was to balance in constant volume systems versus variable volume systems. It was just interesting to see all the different things that it can do.
So, and one of the other things that I like about it is that, obviously, you get that real world experience. I kind of find it funny that, it's like everybody thinks that the grass is always greener. They're like, oh, I want to become a design engineer, and that's going to be the pinnacle of my career. And you get there and you're like, no, not so much. It's you can make money doing just about anything, whether you're a skilled trade or whether you're an engineer. It's just what you like to do. And I like the fact that you went into, controls or not controls, but test and balance. And then you saw the, design engineer, you went there, any sort of regrets, or what were some of your concerns going from test and balance to becoming an engineer?
Well, I was worried about it, initially, but I always thought that, I'm working with engineers. They still have, very similar knowledge, and they could help me with any, questions I had. which was which was really nice. And it was just I guess one of the regrets I had was the types of buildings that were done at that company were just, pretty much just schools and office buildings. So they weren't very complicated. When I was at Engineering Balance, we were doing everything, hospitals, which are extremely interesting, laboratories, and indoor grow facilities, just all these interesting buildings that not a lot of people get to see, but when you're at a prestigious company, you get to see them. And that was one of the things that I liked about Page is, I got to continue that and go to these interesting buildings. I've done some jobs at NASA, some jobs with Exxon, and they always have interesting projects to work on.
Yeah, I think that's one thing that people maybe don't understand or maybe miss on occasion is that, when you're working for a design engineer, not all design engineers are the same. They have different markets, they have different clients. I know I've worked for different AE firms that, when you're going out the door, they're like, "Oh, you're going to miss the type of work that you're doing," and it's like, you know what, maybe not so much. It's doing the same type of stuff. It can be rewarding, absolutely, and but in the same regards, there are other companies that you just get a whole host of different, interesting kind of projects to work on.
Right. Yep. And so when I was talking to people at EAB, a lot of them, it seemed like the consensus was, design engineer was the next step. And from what I've seen, it's not truly the next step. Is you can actually stay and test and balance and make roughly the same amount of money, and in some cases more money, because you get overtime pay and double time on Sundays. And you can make just as much and see just as complicated of issues that they see over in engineering. And so it is just like, if you like working with your hands, stay in test and balance, because you'll be sitting at a computer as a design engineer. And a lot of them actually don't go out into the field and review their jobs, after they're complete. They don't even see, the product of what they've accomplished. And that's kind of disappointing, because you don't get that feeling of accomplishment like you do in test and balance. When you leave the site, you see everything working, you see all the temperatures, in all the rooms roughly the same, and it's a good feeling.
Yeah, and it's one of those things that, as an engineer, exactly, you don't really see it. You don't get out in the field. Only a select few actually get to go and review, on a couple of times. Usually it's after or before the ceilings get put in and after everything is done is typical. What you do as an engineer, and as a test and balance person, you actually get to see, you have the finished design in your hands, and you actually get to see the results, because everything's done. You're just balancing everything, and you get to see kind of, okay, here's how it evolved, because it's not going to be exactly the same. It's going to be, the intent's going to be the same, but it's not going to be the same exactly. So that's the one fun thing, I think, at least about the test and balance, that you'd be able to see that, going out.
And that is true. And I should go back on what I said a little bit. I never got to go out into the field because I was not the project manager, and so I never got that nice, accomplished feeling. It was, as soon as I got one job out the door, I was starting on the next.
Yeah,
and I never got to go out there.
and just from, my experience, it's been, that's not uncommon. That's exactly, if you are not the most senior member, if you're not the person representing the project, you're not probably going to get out into the field. And as a design engineer, that's absolutely critical. That's probably one of your benefits of coming from probably made the transition so much better, is that you have all this test and balance background, and you're going into the design field, and exactly, you put a VAV box down, exactly, oh, I'm going to put it over here. Well, why are you going to put it over here? Well, because there's light fixtures, there's piping, there's all these different things that I want to avoid. And you're able to kind of, place things and organize things in a manner that makes sense to the installation of the project. And without that perspective, you just can't get that. So it probably gave you a leg up. I think most people get hung up on, drawing. They're not going to be able to draw. As a design engineer, I don't think anybody goes into, being a design engineer knowing how to draw. It's something that's taught along the way. Even CAD jockeys had to start from, square one.
Right.
With different software, with everything. When you go into a design engineering firm, you're probably going to have to learn a whole host of new software, and that's usually not a big deal. But it's not something that's going to be held against you, because everybody has to go through that, and you're going to catch up eventually. So having that knowledge is kind of king. And I know you and I have talked before about just having the experience of being a test and balance person really does give you that perspective. And I know that you had a story about one of your previous mentors saying something about test and balance and being an engineer and how
Right. Yeah. My old boss at EAB, Engineered Air Balance, basically said that he wished that all engineers started out in the field, doing test and balance or mechanical contract or something in the field, so they could really see, how it was in the field, and they wouldn't have as many, I guess, just kind of fundamental mistakes on the drawings that you think could be avoided if you had some field knowledge. But it's funny, because while that's true, the problem with that is once you go into the field, it's more difficult to transition to design, even with a degree. I think I looked for a year and a half before finally a company took a chance on me and actually hired me. I had a lot of interviews, and people basically said, well, you don't have experience with Revit, which is true, but I didn't know how to get experience with Revit, because at the time there was no, there's really no videos on YouTube. There was, nothing I could do to practice that software. I had practiced some AutoCAD a little bit, but with Revit, there was nothing, especially like back then you couldn't get a building model and then just draw ductwork through there and practice doing that, because it just was difficult. So the only way I could really do it is either by paying a lot of money to take the class or getting lucky and getting hired.
Yeah, that is hysterical. It's because I listen to that, and I'm like, like I said, I'm like, nobody knows how to draw coming out of college. Nobody knows how to draw. It used to be back in the day, you'd have drafting classes. Drafting on a drafting board would be completely different, but you're just drawing, you're copying and pasting and cutting and doing lines and just squares and different symbols. You have to know the symbol library, and that has nothing to do with whether or not you're going to ultimately be a good engineer. It's like one of those filters that just doesn't make sense. It's like if you're gonna say, I don't have any Revit experience, okay, well, maybe I'm not going to be able to start drawing right away. But what I do draw is actually going to make sense, so I'm going to actually save time. So if you're out there, if you're hiring people, just put down the Revit a little bit. Don't BIM modeling. Okay, just slow your roll. Focus on actual field experience, actual in-field experience.
Right. Yeah, and because I was able to pick it up quite fast and keep up with just about anyone in the end. So
right. It makes no sense. So if you're out there interviewing, just realize that. If you were being a punk and just threw it in their face and go, really, is that really the why you're not hiring me? Because that just does not make any sense from a logical standpoint. So, but one of the things that I wanted to do, I have a couple different topics that I wanted to pick your brain, because I know that you've had a lot of experience with, actual, commissioning and being in the field. So I wanted to kind of touch on some common issues you've seen, some uncommon issues, and then get some best practices. So I think that we have lined up some three different common issues that you've seen kind of occurring again and again. So can you kind of dive into those for us?
Yeah, the first common issue I've seen is chill water pipes and duct work being installed over variable frequency drives, and really I kind of reference the NEC 110.26 code, which is really for dedicated electrical space equipment. It's basically states not to install piping and ductwork over electrical equipment, to avoid condensation and things like that. And I've written that up in the field where you have a VFD and someone ran chill water piping over it, and which you could run into issues with that. Like if you run, 42-degree water through that piping prior to it being insulated, if you, if you're 5 years down the line and someone's been bumping that insulation, or it's just deteriorated, it wasn't installed well and it's just deteriorated over time, it can start to condensate and drip on those VFDs and ruin them, which, obviously VFDs are not cheap. And no one wants that to happen. So what I've done on jobs is I have always written up as a recommendation to install some shielding over the VFD to prevent that from happening if they do route chill water piping or ductwork over it. And I've had engineers argue with me when I reference the code and say that's not what the code's for. But my response is it's the intent, not necessarily that the code doesn't apply, but it's the intent of the code is to protect this equipment in case condensation happens. And I think the same thing could happen to a VFD.
Absolutely. And I think that, as commissioning agents, we think of, protecting the equipment from the owner's standpoint. From the engineer's standpoint, it might be something he might interpret that issue as, oh, I missed something. It's going to cost extra money, and that's going to reflect that on me. It's like, I cannot admit to it a mistake, so I have to say that code doesn't apply to it. So I didn't do anything wrong. When the simple response was, hey, just let's protect this. Because like you, I've seen this over and over again, and these VFDs. They're not just put in, you just don't have one VFD. Typically you're gonna have two VFDs, 3, 4. You're gonna have a bank of VFDs that you need to protect and make sure that they don't get damaged. They're probably one of the more susceptible pieces of equipment in a mechanical room, so you want to be able to protect them and baby them. I mean, there's people I've talked to, different commissioning engineers, about even the dust, being even starting them up and protecting them from the construction dust in the mechanical room, because that's typically let's be honest, it's the last place to get cleaned up in a project. So there's a lot of dirt and debris and dust floating around, messing up all the electronics. So they're just little computer fans that are pulling the air through the the circuitry to make these things work. So it's really kind of like, don't start those VFDs up too early, and let's protect them a little bit more.
Right. Yeah. And I've seen filters installed. They put roll type media filter over the VFDs to protect them, and I've actually seen them installed on the outlet instead of the inlet. So I've moved those before.
Yeah. Just use your hand, just figure out where the airflow is going, okay, and figure out what the intent. We're not trying to, clean the mechanical room air. So what other common issues do you have that you have?
Another one would be outside air control for demand control ventilation. Essentially, a lot of times I see sequences are pretty vague for this type of control. they just say, please provide demand control ventilation, and outside air damper shall modulate to maintain airflow set point. And then in the demand control ventilation sequence, they say, if low parts per million in the space, like below 700 parts per million in the space, damper shall go to 25% of max. And then if as the parts per million rise, the CO2 rises in the space, then damper shall go to 75%, instead of just saying, hey, just modulate maybe on a linear reset between this CFM value and this CFM value, instead of using damper positions when you have airflow stations and you've already stated to control based on airflow in your outside air sequence. And so it's aligning those two sequences properly, and then also verifying that your outside air set point is being maintained through all modes of operation for the air handler. So let's say you have a variable volume air handler that's going to modulate between 30% speed and 100% speed. Well, obviously it's going to pull in less airflow when it's at 30% speed. And I've seen situations where the outside air damper is 100% open, the return is 100% open, and it's just not getting its outside airflow set point. And so some people, to correct that, they either software link or manually link the return air damper and the outside air damper. But the problem with that is, if your return is sized for full flow, full supply flow, and your outside air is sized for roughly 30% of the flow, then you're actually adding inlet restriction to the air handler. So the fan has to pull harder, which is not good. So I guess the suggestion would be, in the sequence, you could say, modulate outside air based on outside airflow modulate the outside airflow damper based on outside airflow set point. And if you cannot maintain outside airflow set point and your damper is 100% open, then you can modulate the return. So you don't modulate the return damper and the outside air damper at the same time. You make sure that they operate independently, but you're always keeping one damper 100% open so that there's less restriction on the unit.
Absolutely. And I think that when you were talking about the demand control ventilation, I think engineers out there, make sure that you spend a little extra time understanding what demand control ventilation is and what your equipment can do.
Right. And I've seen, a lot of times that the engineer will not put maximum outside air set points and minimum outside air set points. So I've been on jobs where, they've been occupied and they have the minimum outside airflow set point is 0. And so then, when the building is not as occupied, you're basically getting no outside air into the building, and the exhaust is pulling the building negative, which then you'll get infiltration and potentially mold issues, especially down south with all the humidity that we have.
Right.
So it's important to make sure that, when the unit's at minimum, that you're always maintaining your building pressurization. So that's the importance of having a good sequence and making sure you're properly pressurizing your building at all times in all modes.
All right. So what's the third common issue you have for us today?
The third one I have is integration with packaged equipment. So I'm seeing this more and more where the coordination between the mechanical contractor and the controls contractor and the engineer for packaged equipment just doesn't seem to be happening on a lot of jobs. And so essentially the engineer has a sequence of operation he wants to be he wants, and the mechanical contractor is going to purchase this packaged equipment that's supposed to be able to meet this sequence of operation. And then the controls contractor is just going to bid to monitor this equipment. Where I see more and more pretty much all the jobs I've done, where the controls contractor actually has to take over control of some part of that equipment to be able to do the full sequence. And it's not properly looking over the sequence of operation prior to bidding the job that really creates an issue. And some jobs I've had, they delay a year getting this equipment to fully operate correctly just because there's that fight between who's going to take control of this unit and who's going to control what. One example that we had was the engineer had an airflow station in the return and an airflow station in the supply. And he wanted those two subtracted to get the outside airflow and control, the outside air damper based on that number. And so there's not a lot of equipment out there that has an input for a return airflow station and a supply airflow station that can also do the math and then control the dampers based on that. So the controls contractor had to take over the dampers and the airflow station inputs to be able to do that control.
Yeah, all too often it's, you ask controls contractors what exactly they can do, and they're like, well, we can do anything, for a price. But,
Right.
especially when you're talking about, okay, everybody just, it really falls down to the engineer. The engineer specifying a certain piece of equipment. They put it on the drawings, they put it on the schedule. Contractor, they just buy what the engineer tells them to buy. And they don't necessarily know if it can do what, the control sequence says it can do. And then you get into this problem where you put it on the controls contractor to make it work, and they just go, not with this piece of equipment, and it's when you're talking about taking over, you make it sound, you kind of make it sound a little bit more pleasant than you is. I mean, or more pleasant than it actually is, because you're ended up ripping out the intelligence of the existing piece of equipment, and these are typically going to be, packaged rooftops. They're finely tuned. They know exactly what they're going to do. They can do what they do very well. But when you try to force a sequence on it, you have to rip out all the intelligence and then replace it with something that probably wasn't in the bid scope at the beginning of the job.
Right. Yep. And that just goes into that coordination and properly reviewing the sequence prior to, providing that piece of equipment. And, don't order the dampers or make sure that, not the dampers, don't order the actuators, or make sure that the actuators you order, that the controls knows that they will have to take those over and do that logic.
Right. All right.
And,
okay, go ahead.
Oh, I'm sorry. Go ahead.
So what are some of the uncommon issues? We've talked about a lot of the common issues that I think a lot of people who've been in the industry, they've typically seen. But anybody who hasn't, this is probably new to them. But some kind of uncommon issues that you've seen from project to project.
So one uncommon issue, I had done an airplane hangar a little while back, and essentially in the hangar portion of the building, they had these bay doors that would open, and obviously an airplane would come in, and then they would close. And so when they closed, they wanted these two air handlers that served the space to go into what was called a purge mode, and essentially quickly get that hangar down to, a comfortable temperature. So the issue was that the lag chiller kept tripping off, and they were trying to figure out what was happening. And because they'd have to go out there and reset it. So after a little bit of testing, we found that when the air handlers went into this purge mode, they would, open their chill water valves, and they would require a lot of GPM. And so obviously the lag chiller would stage on, and, lag pump would stage on to maintain that flow and temperature. And then when purge mode temperature was reached, then they would just close, quickly. And all of a sudden that would hit low flow on the chiller, and it would trip off. And so we basically recommended to, slowly close that valve so that the chiller would have time to, stage down and shut off naturally when it went below pretty much 40%.
Yeah, I mean the chillers are notorious. I mean anybody who's done commissioning with chillers understands that you really can't force the chiller to do anything. It's one of the most boring pieces of equipment that you're going to try to control and manipulate. It takes a long time. Yeah, you might as well be watching paint dry. But definitely, that's if you're going to try to force something. Force a chiller to do something and force it to do it quickly, you're going to be on the losing side of any sort of battle.
Right.
All right. So what else do you got for uncommon issues?
Another one I've run into, because I just don't do VRF systems that often, even though they're becoming more prevalent. So I guess I'll probably be running into them, in more office buildings and schools in the future. But one issue that we had, which was for a daycare, essentially, we weren't able to functionally test this building because it wasn't ready until about 6 months after it had been operational and occupied. And they had a lot of issues with the spaces being extremely warm, like roughly, 78, 80 degrees, way too hot. And so when we started our functional testing, we wanted to figure out immediately what was the issue with that. And so what we found was these units are concealed ducted units serving the spaces, and they had a dedicated outside air unit feeding them air, and they also had a return, obviously. And so the dedicated outside air unit was designed to feed them 55-degree air, and the return came back at 72 to 75 degrees, and so it mixed at about 60 degrees, and that's what the return sensor would see, and it essentially became a mixed air sensor. So it would always see about 60 degrees, and we found out that the unit was operating based on its return temperature sensor instead of its space temp sensor. And so it was the way that it was set up initially. And so we reset up the thermostat to operate based on space temperature, and that pretty much immediately fixed the issue. But it was just surprising to see that, after 6 months, it took a couple hours to figure that out,
Right. You think, usually with the VRF systems, aside from the fact that you have a dedicated outside air system, VRF in and of itself is pretty, cut and dry. There's not too much about it. But, if you don't get it set up right, it's not going to work. And that's, I see that a lot with some of the VRF systems that I've worked on. And then, there again, it's just who's setting it up. They don't really understand what the sequence is, what it's supposed to be doing. And, they don't have that, resource or knowledge, or even the ability to know that that's a question that they should be asking. So I think that's
right. And
go ahead.
Right. And the VRFs are really interesting systems, and they work extremely well, but they have a few things that are different than normal systems, like their fan control. It's not always the same as like putting in a series fan powered box. That just stays at a constant speed. But if you put in these VRF systems and you put them to auto, well, then the fan's going to be modulating up and down. And so the airflow can drastically change in the space. And so if you're designing those grills for a specific throw, then, it's just one of those things that engineers may want to think about on their sequences, is saying, hey, these always need to be set at a single speed, or it's okay if they're put in auto to modulate between, 20% and 100%.
All right. Good stuff. So let's move on to best practices. What sort of best practices do you have to share with us today?
So the first one, I had heard a while back from another commissioning agent is he always said that he looked at his issues log at the end of the job, and he found 100, 200 issues, and he thought he was doing a good job. He found all the issues and would get them corrected. But really, when he thought about it more and more, he thought, maybe I'm not doing such a good job, because if I was doing a good job, I should have zero issues, because I would have done all my pre-work, my design reviews, everything, would have found all the issues prior to the end. And I would have, helped coordinate with the controls contractor and everything to where there would be no issues. Now, we all know that's impossible to get zero issues at the end, but you could try and get close. So the way that we try and do that is we implemented at Page, we implemented a control coordination meeting, which essentially we invite the controls contractor, the engineer of record, the mechanical sub, sometimes test and balance, and we always invite maintenance to join in if they want to. And then what we do is, this is after we've written our functional tests. We'll sit down with the current sequence of operations, our functional tests, and we'll just go through them, pretty much line by line, and just make sure everyone is interpreting the sequence the same way. So this happens before programming, so that when, controls understands the intent of the sequence, and then they know what they have to do to move forward and program. And so hopefully there's no surprises when we go to functionally test. They can take our functional test and run through it themselves, verify everything's working, and then they call us out, and then they just demonstrate a fully operational system, and we'll fly through it. We'll pass everything and move on to the next job.
This is a excellent best practice, and if anybody isn't doing this, they should put it on their list. I mean, flat out, one of the issues, just from a multiple standpoint, you have the design engineer who doesn't always, put every single detail, every single set point on his sequence of operation, and this kind of covers that. If you have the temperature controls contractor kind of having questions, or, hey, we can't do that, or how about we do this, that gives them the opportunity to go back and, program it once. If anybody has dealt with temperature controls contractors at all, it's if you're making them do something twice, it's going to cost you. If you can make them do it once, then there's a lot of things. There's a lot of leeway that they can, put in there, even if it wasn't in the original contract documents. They'll go ahead and make that change, because ultimately they're going to be the ones called in if something doesn't work. So they're very forgiving when you do this ahead of time. And then the third aspect is that you have this can play out in various different ways, but by like what you said, inviting the maintenance people there. You might have a piece of equipment that they don't know exactly what it does or how it operates, and they may have some preconceived notions on, hey, I want it to do this. And if they understand from that standpoint before anything goes in, how things operate, you get a lot more buy-in from the owner saying, okay, this is exactly the system that they said I was going to get. I know how it operates, and they get a little bit of learning ahead of time. So it really does, this training aspect to the maintenance crew really does help out. So, you really got the trifecta there as far as this controls coordination meeting. So if you're thinking about it, if you're thinking about something new to do, and you aren't doing this, definitely go ahead and start implementing this, controls coordination meeting. I think it's a great idea.
Yeah, we've had a lot of good success with it. Especially since the engineer is there. If changes need to be made, they can be made pretty much on the fly. We take meeting minutes and we copy everyone and send them to the engineer. So if he needs to, do a quick, turnaround on a sequence or something like that, he has all the notes just to go off of, and he can make any edits he needs and quickly send that out so that the controls can implement it in their programming. But we have had some issues with it in the past where, especially on integration jobs, we say, hey, here's the sequence. Mr. Controls contractor and mechanical contractor, can you guys pull this off? And they just say, yeah, no problem. But then when we get to the end of the job, they don't even get close. And then they say the equipment isn't even capable of doing it. And why didn't you bring this, up months previous when we had this meeting? It would have saved us a lot of headache. And so the meeting is what, everyone makes it.
Yeah. You gotta be honest, garbage in, garbage out. So everybody has to be on the same page. All right. So, what about the other best practice that you have for us?
The next one is more of a test and balance best practice, and I think it's best if there was more traversing done on projects. And the more reports I review, the more I see less and less traversing listed on there, where it's less and less pitot tube traversing. They'll still do traversing, but they do it with a Velgrid or a anemometer. And the problem with that is those tools are really they're proportioning tools. They're not calibration tools, so they don't truly give you a good accurate airflow. It's best always to do a pitot tube or airfoil traverse. And especially when you're establishing your AKs at the beginning of the job, and then you're at the end of the job, you're finaling the air handler, you can do a total traverse and just verify your box total is good. And it gives you a warm, fuzzy feeling when, you do your traverse and you find it's plus or minus 5% from your box total. It's a good feeling to know that you did everything right, essentially, and you can just walk away and know that it'll work.
All right. I'm gonna back up a little bit just to make sure that everybody is on the same page here. So when you talk about AKs for the diffusers, what are you talking about?
So yeah, if you look at the schedule, you'll have a device schedule for your grills, all throughout the job, and so usually there's like 4 or 5, sometimes more. And if it's just a standard 2x2 grill, then your AK or correction factor for that grill for your flow hood is probably about a 1.0. But if you have, maybe a linear slot diffuser, then your correction factor for that grill may be a little different. And so what we do to get an AK for a linear slot diffuser is essentially we find, a slot diffuser that's doing roughly the, an average of the design CFM. So if they're all designed for like, 200 CFM, 100 to 200 CFM, then we pick one at like 150 CFM. And then we find one with a long duct run, nice, so we can have nice laminar flow. And then we'll do a traverse, right? A pitot tube traverse. And then we'll read that grill with our flow hood, and we'll compare the two. And so generally on those, you get, plus or minus 10%. And so if you read, 165 CFM with your traverse and 150 CFM with your flow hood, then your AK is about a 1.1 that you'll apply to all the grills going forward. And then it just gives you a greater accuracy, as opposed to being 10% off all the time. Then you'll be right on what your traverse is. So when you do a total traverse at the end, you should line up.
Now, is that something that you're going to see on the balance report, that AK correction factor?
Sometimes you do. At Engineered Air Balance, they always put it on their reports, but it's not on every report. And it makes me more wary when I don't see AKs, but I see slot diffusers and sidewalls where I know a hood reading is less accurate.
Yeah, and I think that it's very important to understand that, with anything, whether it be commissioning or test and balance, especially test and balance, you have to have this sort of scientific method going on, that you want it to be repeatable. You want your document to stand on its own, to say, hey, you know what? If you're going to take a reading, here's the correction factor, and you should get a similar reading to what I had. It's not going to be exact, but it's going to be a very similar reading, and it really goes a long way for repeatability. So I think that's very important.
Right. And the best you can really hope for in the field is about plus or minus 3%. That's about as accurate as a traverse gets.
So now backing up and just understanding, now it's kind of hard to, every time we try to describe a Velgrid, or an anemometer.
Anemometer.
Yeah. It's one of those things that's kind of hard to describe. But we'll link it up in the show notes if you want to actually see a picture, or you can just Google it yourself. Either way, but those are exterior ways of measuring airflow. They're not as accurate. Typically, I see them as they're the options of last resort, so to speak.
Right. And actually there are some guys at EAB I remember talking to, they said that they would never use a Velgrid ever again. They had one bad experience and said, I will never use that tool. And so they only use a vane anemometer essentially.
So now the traverse is a little bit different because that's more of intrusive. So a traverse, if you don't understand, and you're talking about traverse and pitot tubes are kind of what they sound like. They're just tubes with holes in them. But you're able to drill a hole or a series of holes in a piece of ductwork to get an average velocity. And so that's you actually get inside the ductwork, whereas the Velgrid and some of the anemometers are kind of exterior. You're looking at it from the outlet side of it.
Right. Yep. And yeah, so a pitot tube will measure the total pressure and then the static pressure, and it'll subtract the two at the digital manometer, and it'll calculate a velocity pressure. And then from there, you'll put it into a little formula, and you'll calculate your velocity, and then multiply that by the area, and you have the CFM.
Voila! It's like magic. Now, are those some of the things when you look at a bouncing report? Are those some of the things that you see that are identified, whether or not it's a traverse or a Velgrid? Are those standard?
Yeah. So yeah, looking at a traverse, generally they will say at the top what instrument that they used, and for the most part, just about everybody just lists the velocity. They don't list the velocity pressure anymore. Engineered air balance will still list the velocity pressure, and then they do the 4,005 times the square root of velocity pressure will equal, your feet per minute. And so it's just kind of nice to see that kind of the old school method is still being used. And I would just wish more companies would do it. It's not as necessary because they just shoot it. The manometers these days just shoot it out as a feet per minute. But I think you lose a little bit when you kind of forget that calculation, I guess.
Yeah, it's always good to have that in your back pocket. All right, so any final words that you have for us today? I really appreciate you taking the time to talk with us and give us some of your experience doing commissioning. Anything you want to say, or maybe a best way for people to connect with you?
Yeah, well, real quick, I did want to say hi to this guy, Brandon Flood, which he actually turned me on to your podcast.
Thank you, Brandon.
Yeah, he works for Climate Tech. He's an excellent programmer, which is a controls contractor. But yeah, I just want to say hi to him, and then people can reach me on LinkedIn. Also, www.pagethink.com is the architectural firm that I do commissioning for, and my side company that does test and balance is www.eb-cx.com. And then you can also find that company on Facebook.
All right, and we will link that up to the show notes. All right. Well, I appreciate your time, Thomas, and best of luck to you. And just thanks for sharing some of the information today.
No problem. Thank you for having me.
All right, thanks again to Thomas Cocker for taking the time to chat with us. Check out the show notes for some of the links that we mentioned during the show. You can find those show notes over at hvac360.com/141 for episode 141. All right, thanks so much for listening. I hope this was helpful. If you know somebody who's looking to get educated, consider sharing this episode with them. Or maybe they're just thinking about becoming a commissioning engineer and they just don't know how to do it. So definitely Thomas's example gives a great case to how you can actually navigate the entire system, as it were. Also, as I mentioned at the top of the show, please consider subscribing to my list over at hvac360.com for more trick or treats in the form of weekly updates and other games and stuff like that. So, also, two other things. I'd be greatly honored if people would leave me a rating and review on Apple iTunes or Apple Podcasts, and also jump on over to YouTube. I'm downloading these episodes to YouTube. Even if you don't listen to them there, I'd greatly appreciate you subscribing, because once I get the subscribers up, then I can do some more fun things for everyone. All right, well, that's a wrap for this episode of HVAC 360. I'm Matt Nelson, helping you be the best and the brightest in the field of HVAC. And as always, know what you build and share what you know.